Hello guys, and welcome to this video series that is based on fuzzy logic, its applications and its understanding. So I'll keep this series on the theoretic side, but I will try to explore some practical aspects of fuzzy logic as we go along. So the first video is dedicated to what is fuzzy logic and why do we need fuzzy logic, because fuzzy logic is part of soft computing and which is related to data interpretation, to machine learning. There are really wide applications. So some of you might have already done some machine learning projects, machine learning based projects, and you might be thinking, well, since we already have done it based on discrete values are, for example, 1, 2, 3, right? Fuzzy values are 0 0.1, 0 0.2, from 0 to 1. Okay, so since we have already done it based on discrete values, why do we need fuzzy logic? So I will be discussing that in the first lecture. So let's start with what is fuzzy logic. Alright, so let's start with an example. Okay, assume that you have 7 friends. Okay, so I said assume because if you had them, you would not be watching fuzzy lecture videos right now. Just kidding. Anyway, so assume you have 7 friends. Let's go 1, 2, 3, 4, 5, 6, 7. Okay, that's a girl. Now let's give all these a value. I'll explain what the values are in just a minute. Okay, I gave them ordered values. Let's change this to 0.6 again. Alright, so for example 0.1 is for Megan because Megan's a bitch. 0.2 is for John, he's an asshole. 0.9 is for, let's go with Claire. Okay, so what do these values mean? So this is a fuzzy set. Fuzzy sets are denoted with a tilde on their base, and normal sets are denoted like this. So this is a fuzzy set. Now this fuzzy set has these values. These are called membership values. So for example, this one was for Megan. So what this means is Megan is your friend, but her membership value is 0.1. So this means that how good of a friend she is to you, and the best being 1 and the worst being 0. So Megan's value 0.1 means she is let's say a bad friend. And let's go 0.5 with Clark. Okay, so 0.5 is Clark. So he's neither a good friend, neither the best friend nor the worst one. So let's go with good friend. Clark is a good friend. 0.9 Claire is your best friend. Okay, so these are values that denote how the strength of the member in this set. So 0.1 Megan means she is a weak member of this set, means she is not as good of a friend as say Claire or even Clark. Okay, so this is how you denote a fuzzy set. These are called the members of a fuzzy set, and they have certain membership values ranging from 0 to 1, which are denoted by mu of p tilde of x. X is the element. Okay, so this is the membership. So mu of p tilde for Megan is, I'll call it b fuzzy. I don't know if I'm pronouncing tilde right. You guys might be laughing right now. So 0.1 is Megan. This is for Megan. Okay, we can replace x with Megan. Moving on. Now, confusion for beginners is between fuzzy membership values and probability. because both range from 0 to 1 and both have values like 0.34, 0.43 and so on. So what's the difference between fuzziness and probability? So probability is the chance of a thing happening. So if in the example here where these are your friends, the chances of them being your friends are 1 because they're already present in your friendship set, right? So this is your friendship set. Let's call it friendship set. A fuzzy, and so since they are already your friends, they are included in this set. Therefore, the probability of them being your friends is 1. Alright? But the how good of a friend they are is determined by their fuzzy value. So when we take a fuzzy set, the probability of the element to be in the set is 1. The probability won't change. The chance of that element for being in the set is 1. Alright, it's not 0.5, it's not 0. But the membership value just determines how the strength of the membership. So how good of a friend they are. For example, let's take another example. Let's say you have a crush on someone, okay, and let's say you have had multiple crushes over a period of time. So let's assume now that those crushes liked you back. I know it's a brave assumption, I know, but just bear with me for a while. So 0.7 is for the first crush you had, 0.9 and 0.3 for example. So let's call this B fuzzy. So these are the values with which the crush liked you back. Okay, so now the probability of the crush liking you back is taken as 1 because we are already determining how much they like you. So the probability is taken as 1. The probability of them liking you back is 1. So this paper seems filled. Sorry guys, my recording automatically stopped. As I was saying, if the probability of your crush liking you is 0.5, then he or she won't be included in the membership because you don't even know whether they like you or not. So how can you say they like you this much? Same here. If you don't know someone is your friend or not, then of course you cannot add them in your fuzzy set of how good of a friend they are. Alright, that's why the probability of that element being in that set is always 1. Okay, moving on. Okay, so here I explained why we need fuzzy logic. So in classical logic, the discrete values take are 0 and 1, alright, true and false. But in human language, our language is very vague. That's what I mean to say. So if I say that I really like you and I love you, I hate you, so if I say I love you is 1, then rest all becomes 0. I hate you becomes 0. I really like you becomes 0. That obviously cannot be true. Similarly, if I say I hate you is 0 and I really like you is 1, I love you is 1, I like you is also 1, that does not make any sense either, because in practical life that is not the case. Alright, these are different things. Therefore we need to have fuzzy logic in place which can give us a degree of values between 0 and 1 so that we can express ourselves more freely, and that's why fuzzy logic can be very useful in NLP, because when you are guessing what a person is saying through when you are doing speech recognition, when you are doing text analysis, when you want to guess the context of what the person is wanting to say, then you need to assign fuzzy values instead of discrete values to say, oh, this is the degree to which this person is angry, this is the degree to which this person likes them, therefore she or he will be in the love category or like category or hate category. So okay, because if I say I love someone, for example, I make a program that sorts pictures of people according to the comments I made. So if I say I love someone, they will be in the love folder or the partner folder. I like someone, they will be in the friend folder, not the enemy one. If I hate someone, they will be an enemy. If I really like someone, of course they will be in the friends folder. Okay. Another example, I'll link the blog below. I read in the blog that fuzzy logic can also should be used in cancer treatments. The logic behind the blog was that some cells, when they have when cancer have takes place, then some cells have this much of cancer. Some cells are fully gone. Some cells are partially damaged. So, since we now use discrete logic, 0 and 1, if a cell has even this much cancer, it is considered 1. Partial, 1, full, obviously 1. No cancer is 0. Okay. So the problem is that for a cell, the difference is really small. But in the human body, the distance becomes large because an organ contains so many cells. The difference becomes large. Sorry. So what happens is, even if we consider all cells to be 1, 1, 1, here even partially damaged or fully damaged, if this is 1, this is also 1, then the cancer seems more spread out than it is, due to which we cannot give ideal medication to the patient, because we will think, okay, the cancer has spread this much. Since we don't want to endanger the patient, we will, if the cancer is this, we'll pose it as this so that we do not miss any cells, because our discrete logic isn't as accurate as fuzzy logic. Therefore, the patient will be exposed to more medication, more chemotherapy, and overall a worse picture of the cancer than it should be. Whereas if we use fuzzy logic, then this will not be the case, hopefully, and algorithms are being developed in that sense. I'll link the blog in the description below. You guys can check it out. It's a small blog, it won't take much of your time. Do check this out. Another thing is, using values like 0.4, 0.5 seems pretty straightforward now, but it was not used in discrete logic. It's true, false, 0, 1, right? There's no almost false or almost true. Therefore, although this seems straightforward, this is not being used much in the old case, or in the old projects, or even in many modern projects. Fuzzy logic is not being used because everything is based on the discrete logic of 0 and 1, of true and false, the binary values. Therefore, fuzzy logic has a really wide area to grow. And that's it for this video. I explored the what and the why of fuzzy logic. If it was not clear, leave it in the comments below, and I'll come up with a better video in the next lecture. Thank you for watching, and if you have any questions, to write in the comments, I'll try to answer them.